Yeah, drop, hey, huh.
Yo, what's up guys, this is 𝗪𝗘𝗟𝗟𝗟 and today we're playing handoff from PicoCTF, another binary exploitation challenge. So let's go, we download the files, we see them here, and let's review the source code. So here we have some sizes, max entries, name len, message len, extract, some option messages, and the val function. We see a car feedback 8. Okay. And then we go down, we have three options. Option 1, it checks if we have reached max entries, otherwise we write the recipient's name here. After that we have option 2, send a message to a recipient, and we see that we can choose the index of the recipient we want and what message would you like to send, and it writes it in entries choice message. Okay, and option 3 we see we have to give feedback, and it writes to feedback nameLen, which was 32 bytes, and the feedback buffer is 7 bytes. That means we have an obvious buffer overflow. So let's go and find the offset here. 𝗧𝗘𝗥𝗟𝗟, we take that, run, option 3, we see that it crashed at this here, and 𝗧𝗘𝗥𝗟𝗟𝗟, and we have offset of 20, so we know the overflow offset is at this point. So let's play around with the program a bit. Run, we see add new recipient, let's say 𝗪𝗘𝗟𝗟𝗟. Alright, send a message to 𝗪𝗘𝗟𝗟𝗟. I'm gonna say 0 because that's me, and then stop. Next instruction, I'm gonna say A, B, 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 C, 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 D, 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 D's nuts, and boom, we hit it, and we see that our payload, let's return to val, when the fgets finishes, we see that our payload is stored at this address here, at tracks, and I'm gonna keep it here, write to res. So we have this address, and we can also inspect that to verify, yeah, this is our string. So let's continue, we exit the app, review, next instruction, bye, and we finish. Right before we hit red, right here, we see that RBP contains this address. So if we do RBP minus our current address, we get this offset. So when we do the overwrite, if we subtract from RSP this, we get the offset where we start to write. So we're gonna exploit that. Let's keep the offset here. Offset from RBP and where we write. So we have this offset. Let's try crafting our payload a bit. So here we create a new recipient, r.sendLine, as we tried, let's do 𝗪𝗘𝗟𝗟𝗟 and send message. So right here what we're gonna do, first of all we run a check to the program and see that nothing is enabled, no Canary, no Pi, not even an X. This is what we're gonna exploit. We're gonna use shellcode on the stack to execute it and spawn shell. So we actually wanna store our shellcode inside here, r.sendLine, and we choose 0, which is the recipient we created, and after that we're gonna do r.sendLine, and here we need to insert our shellcode, which is gonna be shellcode assembly shellcraft.sh. So this will create automatically a system bin sh or execv, I don't remember exactly what is it. And after that, what we need to do, we know that fgets reads up to 63 bytes, I think. Message len is 64, so it reads up to 63, and that's a null byte. So we're gonna do rjust here, 63, and then we're gonna have some nope slides. And what else do we need to do? So let's say we're gonna store our shellcode here, r.sendLine cell code. What we need to do right now is actually call this. We know that this is randomized, so we can actually call the stack address, but we have found the offset from the RSP when the stack frame is returning to our buffer where we have inserted our cell code. That's what we're gonna do right now. Let's say jump. We're gonna write some assembly here. First of all, we're gonna have an op slide, an op instruction, so we are safe with our payload, and then sub RSP and the value we have 0x2e8, and after that we're gonna jump to RSP, so this will actually jump right to our cell code. And for the time being, let's just print length of payload, and here I want to see the length of our jump, so Python solver, and we see that the payload is not printing. Okay, and then yeah, like this. And the length of payload right now is 10, so we actually need to fill another 10 nope slides until overwrite of the return address. So we're gonna have nope here, so I'm gonna have it like this. And after that, what we need to do is actually jump to rags, which will contain this address we have stored right here in the cell code. So we need to find a jump rags gadget here, 𝗪𝗘𝗥𝗘 jump rags, and we see we have one right here, r.sendLine jump plus p64 jump rags gadget. So this will actually jump to our cell code, and let's see if we have managed to exploit the challenge. And boom, we got cell. That's really nice. Let's try to do it remotely also. And we see we managed to get cell on the remote instance. That was a challenge, guys. It was a bit tricky. I think there are many ways to exploit it, but this one was the one I thought of. If you have any questions, leave a comment, like the video and subscribe to the channel to support me, and see you in the next ones. Bye.